Hey everybody, in this video we're going to be using law of cosines to find unknown angles in a given triangle. So all the triangles here we're going to be given 3 sides, whereas in the previous video we were given 2 sides and 1 angle. If you want to follow along, the links to the companion worksheet are in the description below. As with all the videos in this playlist, please remember that you have your calculator or computer program in degree mode. So let's get started. So here we have this triangle, and we have 3 sides, and we need to find the 3 angles in order to solve it. So that means we need to use law of cosines. So I'm going to use c squared, so that's 8 squared, equals a squared, that's 6 squared, plus b squared, that's 5 squared, minus 2 times 6 times 5 times cosine of c. So we're going to have to solve for this. So let's see. 8 squared is 64. 6 squared plus 5 squared, that's 25, plus 36 is 61. 2 times 6 times 5 is 60. So we have 61 minus 60 cosine of c. And since we're solving for c, first we have to subtract the 61 from both sides. So we have 3 equals negative 60 cosine of c. And then we divide by negative 60. And what we get is negative 1 over 20. So to find angle c then, we're going to take arc cosine of negative 1 over 20. And since we're going to need that, we're going to have to find an approximation. So arc cosine of that is approximately 92.866 degrees. But now that we have that angle, now we can use law of sines to find the other side, the other angles. So sine of 92.866 over 8 equals sine of a over 6. So we'll cross multiply and divide. And so sine of a is equal to 6 sine of 92.866 over 8. And we'll find the decimal approximation of that. And so sine of a is going to equal 0.749. Again, that's a ratio, not a degree. So now, we're going to find a, we're going to take the inverse, the arc cosine. Nope, not arc cosine, but we're going to use arc sine because we're using law of sines here. So 0.749. So a equals 48.509 degrees. So now that's our second angle. So to find our third angle, we found these two, we take the 2 angles we found and subtract them from 180. So subtract 92.866 minus 48.509. And when we do that, we get b to equal 38.625 degrees. And so there are the 3 angles of this triangle using law of cosines. We'll do the same thing for the next one. Now for simplicity, we'll still solve for angle c again. So c is 4 squared, a is 9 squared, b is 6 squared minus 2 times 9 times 6 cosine of angle c. So, 4 squared is 16, not 36. And then we have 9 squared plus 6 squared, which is 117. And then we have 2 times 9 times 6, which is 108 cosine of c. So we subtract the 117 from both sides, And when we do, we get negative 101 equals negative 108 cosine of c. So when we divide by negative 108, we get cosine of c equal to 0.935. So that means c equals arc cosine of 0.935. And so we get an angle of 20.742 degrees. So that's one of them. So now we're going to need law of sines to find the next one. So sine of the angle we just found, 20.742, all over. Now this is angle C, so side C is 4. So we're going to put 4 in our denominator. And that's going to equal sine of A over 9. So we cross multiply and divide, and sine of A equals 9 sine of 20.742 all over 4. And so we get sine of A to equal 0.797. So angle A is going to be arc sine of that ratio, 0.797. And so we take arc sine of that, and we get 52.831 degrees for A. So that now is 2 angles. So to find our third, again, we subtract from 180. So 180 minus 20.742 degrees minus 52.831 degrees. And so we get B equal to 106.427 degrees. And that's our third angle. So for our third problem, we're given that we have a parallelogram. It has sides of 40 and 60 and a longer diagonal length of 80. And we want to find the length of the shorter diagonal. Okay, so if we draw this, we've got 60 and 60, 40 and 40, and our longer diagonal is 80. And the question is, what is the shorter diagonal? Well, to answer this question, what we're going to need is we're going to need to figure out what one of these angles in the parallelogram is. And once we find one, the others will fall into place very quickly, because in a parallelogram, opposite angles are congruent and consecutive angles are supplementary. So let's call this angle angle C. So that means this is side C, and 40 and 60 are sides A and B of this triangle. And let me highlight that so you can see it. So this is the triangle that we're looking at right here. So we have 80 squared equals 40 squared plus 60 squared minus 2 times 40 times 60 times cosine of C. So we have 6,400 for C squared. For 40 squared plus 60 squared, we have 5,200. For 2 times 40 times 60, that is 4,800 cosine of C. So first we subtract 5,200 and we get 1,200 equals negative 4,800 cosine C. So then we divide both sides by negative 4,800. and we get negative 1/4 equals cosine of C. So angle C is going to be arc cosine of negative 1/4. And so that means C is going to be 104.478 degrees, an obtuse angle, and we expected that because we expected this to be obtuse. So now that we know that, now let's fill in a little bit more. So we've got 60 and 60, 40 and 40, and we've got 104.478. And that's the same over here, so I don't need to write it. And so what's this angle? Well, it's the supplement of that. So if I subtract from 180, 104.478, I get 75.522 degrees. And so what that means is this angle right here, 75.522, allows us to find the shorter diagonal. How? Think of this as a triangle with the shorter diagonal. And so what this becomes is this becomes another law of cosine's problem, where we know the angle, but we don't know the two sides. So this is like a problem from the previous video in the playlist. So now we're just using law of cosines to find this side length. So if I call it C squared, then 40 and 60 we'll call A and B. So 40 squared plus 60 squared minus 2 times 40 times 60 times cosine of the angle we just stated, 75.522. All right. So now this is completely doable on your calculator, so I'm just going to type the whole thing in. So 2 times 4 times 60 times cosine of 75.522. So that means C squared equals 3999.960. So when we take the square root of that, C is going to be 63.245 meters. And so that is the length of the shorter diagonal of this parallelogram. Thanks for watching. If you liked the video, please give it a thumbs up. For more videos like this, click the subscribe button. If you have comments or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.